In addition to analyzing data, we also want to visualize data to help us understand what it is that we're learning from the data. And R gives us a variety of different ways of visualizing data. There are some graphing functions available through the base package in R. Dr. White, I think, also provided some graphing functions as part of TigerStats. Maybe you've used some graphing functions in Lattice, also in Math 111. What I would like to do is I would like to use a package called ggplot2. GG stands for the Grammar of Graphics. So this is a package that I think is relatively intuitive to use and to understand, but also provides a lot of power for designing some really high quality graphs. And in fact, it's becoming in many ways the industry standard. I think most people these days are now using ggplot2. So ggplot allows us to create a number of different graphs. We can create scatter graphs, box plots, bar charts, violin plots, all kinds of different graphs. And so what I'd like to do is show you how to create scatter plots as part of what we're going to do for week 2. So before you begin, we need a data set to work with. And so here's a quick data frame that we can create. If you want to, you can go to the PowerPoint slides and cut and paste these lines of code, and they should work. But what we're doing is we're creating a series of vectors. The first one for family number, 3 families. Then for these 3 families, let's suppose each family has 2 parents, parent 1 and parent 2. And these are heights, for example, of the parents. And then each of these families also has 3 offspring, 1, 2, 3, and we also have heights for each of these offspring. So we're going to create a data frame called PO frame for parent offspring frame, and the data frame is going to have these 6 columns in it. Then we're going to manipulate the data to create a couple of new ones. So we're going to create a new column called pmean for parent mean, and that's going to be the means of the 2 parents in columns 2 and 3, and then an omean column for the mean of the offspring, and those are going to be the 3 offspring in columns 4 through 6. So if you want to, once you do this, look at the data, look at your data frame in a new window and make sure that it works. The other thing that you should do is make sure, before you get going, that ggplot2 package is loaded. So I have done all of this, and so here's what PO frame should look like. Family, parent 1, parent 2, the 3 offspring with parent mean and offspring mean. And I want to check and make sure that ggplot is loaded, so I type in here ggplot, I check it, ggplot2 is indeed loaded. So come back over here to the plots window, and we are good to go. The idea behind ggplot, Grammar of Graphics, is that it divides graphing into, I'm going to summarize it as 3 areas, or 3 main things. The first thing is we're going to use a function called ggplot to specify the data frame, where all of our data are going to come from, and then to specify a graph frame, specifically the x and the y axes in our graph. But once we have the x and the y axes, then we need to figure out what is actually going to go in the graph, what elements are going to go into the graph. And so these are known as glyphs. So we're going to use a variety of different functions. So it might be a geom point, or a geom bar, or a geom box plot, whatever it is, to specify the glyph or the element that goes into the graph. And then within the function we can give a little bit more information about how we like this particular element to look. And finally, there are a whole bunch of other functions that can make the graph much more readable. So for example, we might want axis labels, we might want legends, we might want to specify things like guides and scales, and so on. So let's start with a very simple bit of code over here that just gets us a minimal graph with the axes and with a glyph. So we're going to create a graph object. I'm going to name this graph object PO graph for parent offspring graph. This is an object like a vector or a data frame, but in this case it's a graph. And so we use our assignment operator over here. Oops, I need to do that. Assignment operator. The first thing we're going to do is we're going to use the ggplot function. And so in the ggplot function, our first argument is the data argument. So our data frame is the PO frame. Then we're going to tell it how to map the data. All right, so mapping equals AES for aesthetic. We're going to have on the x-axis p-mean, and the y-axis o-mean. And then we want to say plus over here. So we're adding a new part to the graph. The thing that we're adding is a geom underscore point, and we're not going to say anything specific about the point, so we're just going to leave this function empty. We run this line of code, and then if we run our line, say PO graph, if we run the object PO graph, we should get a graph that looks sort of like this. Right? So we see our x-mean, our x-axis, our y-axis, and our 3 data points graphing the parent means versus the offspring means. Alright, so now let's try modifying this code to make it look a little bit better. So again, we have our object PO graph over here. We haven't done anything to change our ggplot function. We're still going to say that the data is in the PO frame, and we still have the same x and the y axes. We also have geom point, but notice we've put some more information inside our geom point object. We said size is 4, so the size of our points is going to get a little bit bigger. We're going to specify a color, and there are a lot of named colors. So a simple color is red. Color equals red. We have to put red in quotes. And then finally, we have all sorts of different shapes we can use. The default shape is a circle, but shape 18 is a diamond, so that's a good shape to use. If you want a different looking shape, all right. Plus, again, we're adding one more element to our graph, and we're adding labels with the function labs. So the x label would be mean parent height, comma. The y label is going to be mean offspring height. Centimeters. And finally, let's add one more object over here. Let's add a theme object, and our theme object is going to be about the text, and the element text, that's the text that we see here for the axes, is going to have a size of 15. All right, so we run all that, we run PO graph again, and we should see the following graph. Now, if all this is seeming a bit complicated, don't worry, you don't have to memorize all of the code over here. For graphing, what I really want you to be able to do is simply look at the examples that I've given you in the lab manual, or that are in the PowerPoints, or that you find online, and be able to create a graph that looks the way you want it to look. But I don't expect you to have all of this memorized. All right, so the last thing to do is let's add one more element to our graph. Do it in a slightly different way. Let's create a new graph object called PO graph underscore line. So this is going to be different than our original graph object, but we're going to build on our graph object. So we're going to take our PO graph object, and then we're going to add to it one more element. We're going to add to it a line. So this is geom smooth for a smoothing function, and a method is going to be lm for linear. And we could have a variety of different smoothing functions. It wouldn't have to be linear, but this one is going to be linear. And we can have our line with standard errors, but sometimes that can look a little bit odd. So we're going to say SE equals false, standard error equals false. All right. Again, make sure that you run the PO graph line, and we should get a graph now that has a blue line running through it. All right. So the last thing that's really helpful to be able to do is to export the graph. So to do this, let me show you how to do it on R. So here are my various lines of code, and I have these pre-typed in to save time, so I'm going to run them for here. All right, and then I'm going to run my PO graph line graph. All right, so I can just highlight it and run it. And notice in the plots window now, I get the graph. And if I want to make it bigger, I can click over here and make it bigger, and it should readjust. That's good. But now to export it, I have a couple of options. I can just save it as a PDF, which is pretty straightforward, or save it as an image. So if you want a PNG or a JPEG or something like that, you can do that. Give it a file name. I'm going to call this scatterplot1, and this is then going to be saved to the home directory. I can change the dimensions if I want to over here. So I'll click Save, and then when I come over here to File, oops, have to do a refresh, I bet. Yep, here's our scatterplot1 JPEG graph. So if I want to export it, I can just click on that button, click Export, and then this gets saved to my hard drive wherever I want to. So I'm going to cancel that for the time being. The other way that you can do it, it's a little bit faster, is just come over here to Export, say Copy to Clipboard. Again, you can specify the dimensions over here. Click Close, and now you have something that's in your clipboard that you can paste into a document if you want to. So a couple of quick techniques for exporting graphs. So here's a practice problem for you to create a graph with parent 1 versus parent 2, and make the points blue and relatively large, and label the axes height of parent 1 and height of parent 2, and if you want to, even add a regression line to your graph. So here's how this will work. I'm not going to save it as a graph object. I'm just going to write the code out, starting with ggplot. Starting with the ggplot function. So the data is going to be in our PO frame graph. Mapping axes, AES, the X is going to be parent 1, and the Y-axis is going to be parent 2, close out our parentheses, plus, and then I like to do a new line for each element that's being added to the graph, just so it doesn't get too complex and difficult to read. So the next thing we need to do is we need to add a glyph, which remember are called geomes. So geome, and our glyph is going to be a point again over here. Now what we wanted is to make our points look interesting, so let's give them a reasonable size. Size is, let's try 3, and make the color, let's try green, just for the heck of it. Alright, close it out. We're going to add another element, and we want to add labels this time, labs. So our x-axis is going to be the height of parent 1. I don't know what the units are. And our y-axis is going to be the height of parent 2. Okay, and that's the end of our labels element. So one more, and let's then add a line. So this is one more geome over here because it's a graph element. So it's geome smooth, and it's a straight line. So method is m over here, and if we don't want to see the standard error, we say standard error equals false. And if we run this, there we go. We see a new graph. Height of parent 1, height of parent 2. Our green dots over here are points, and here's our best fit line. And so it doesn't seem that there's a particularly strong correlation between the height of one parent and the height of the other parent. All right, and so that's how you would create a graph, a scatter plot graph. So key skills over here: be able to create a scatter plot, or be able to create a plot in general using ggplot2. Modify the graph by changing the axis labels, point color, and point shape. And finally, be able to add a regression line to the graph if it's a scatter graph. Very good. Hope this helps as an introduction to graphing, and if more graphing tutorials are needed throughout the semester, I will be glad to add more videos.